What is up, guys? First video, super fun, super exciting. Wanted to take some time. We left off, last thing we did in class was our Chapter 7 review. I had assigned that, so I wanted to do a couple of the problems from there, specifically numbers 5, numbers 12, number 17, and 27. And I'll have timestamps in the description for the beginning of each of those problems that I do in this video. But we're going to start with number 5. Okay, start with number 5, which says the cotan of the cosecant, or the inverse cosecant of the square root of 10. Okay, square root of 10. So we need to think cosecant that goes with sine. Okay, so if we're drawing an angle, remember inverse of anything, really, what is this saying? This represents an angle. Even though we don't know what the angle is, if we draw it, we can find the cotan of it. So this goes with sine, and it's positive. And if you remember anything about inverse, sine goes with from negative pi over 2 to pi over 2. So quadrants 4 and 1. And this being a positive root 10, that means we're going to draw our angle in the first quadrant. So draw our angle. Okay, and cosecant, again, is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So how do we get root 10? I only have one number here, right? Think about what is the denominator of this one. Root 10 over what? Root 10 over 1, right? So this is root 10. This is 1. Okay. We want to find the cotan of this angle here, this angle theta. So cotan will require this x because it's x over y for cosine. So let's find that using Pythagorean's theorem. If this is x, we should have 1 squared plus x squared equals root 10 squared, or 1 plus x squared equals 10. Subtract the 1 to get x squared equals 9. If you square root that, x is going to be 3. X to be 3 there. So what is the cotan then of this angle? Even though if I don't have the exact opposite degrees, I can find that. Again, that is x over y. So 3 over 1, which is fine. Just writing that as 3 would be perfect. So, okay. Answer to number 5 is 3. Okay. Let's move on to number 12. Establish the identity. Okay, number 12. Number 12 says to establish each identity. We have the sine of x times the times the tan of x plus cosine. This needs to equal the secant of x. So let's work with that left side, see if we can't make that equal secant x. We'll probably end up with a 1 over cosine somewhere over here, and that will lead us to the secant x. So let's rewrite tan as sine over cosine. Sine of x times sine x over cosine x plus cosine x. Okay, so that's the first step. Next step, let's rewrite that just as sine squared, because sine times sine is sine squared. So we have sine squared x over cosine x plus cosine x. If I want to add these two things, okay, and the denominator here is cosine, and the denominator here is 1, I need a cosine in the denominator here. So if I multiply this by cos over cos, it should give me a sine squared x over cos plus cosine squared x over cos. Same denominator, so I can write those over each other, or I can write those together, I mean. So sine squared x plus cosine squared x over cos x. Now who remembers what this whole thing is? It's 1. Good job, everyone. This is 1 because we have our Pythagorean identity. So if we change that to a 1 over cos x, what is that equal to? That is equal to secant x, and that is what we called our reciprocal identity, right? Reciprocal identity. Okay, hope you guys followed that. I'll zoom out so you can see all of it at once. Nice thing is you don't have to worry about holding me up or anything like that. Not that any of you guys ever did that. But you guys can pause videos and make sure to ask any questions and comments either in YouTube or Google Classroom. I'll get emails for whatever, and I'll respond to however you chose to communicate with me. So, all right, let's move on to number, what did I say, 17? Okay, 17. All right, we have the cosine of 15 degrees. Right, cosine of 15 degrees. So we need to write that as a sum or difference of our special angles, which are 30, 45, and 60. And if we're trying to get 15 by writing that as a sum of 30, 45, or 60, that's going to be 45 minus 30. So we want to rewrite this as the cosine of 45 degrees minus 30. And I'm not going to make the same mistake twice. I hope, as you can probably hear me flipping through to pull that one up. Okay, so cosine, this is our sum or difference formula. Let me write that down up here. If you recall, the cosine of a minus b, this is equal to the cosine of a times cosine of b plus sine a times sine b. Okay, that's my difference formula for cosines. So if I'm trying to find cosine 45 minus 30, that is going to be the cosine of 45 times the cosine of 30. Adding to that the sine 45 times the sine of 30. Okay. So remember, we get all of these values from the unit circle. If you haven't memorized, it's a good idea. You guys are probably dancing around rejoicing right now because you guys get all this stuff. Because how am I supposed to keep you from, I think I already gave it to you anyway. Plus I made that mistake, so you get the sum or difference formula too. But either way, you guys are working at home, so you have all this stuff regardless of what I tried to do. So remember cosine 45, if you look on the unit circle, that should be root 2 over 2. Remember, cosine goes with x. Cosine 30 is going to give me root 3 over 2. Add to that, the sine of 45 is root 2 over 2 times the sine of 30, which is 1/2. So just a little bit of simplifying here to do. This is root 6 over 4 plus root 2 over 4. And leaving it like that is fine if you wanted to. Root 6 plus root 2 over 4. That works as well. It's a little nicer because we have to write 1 less 4. But that is my answer to number, what do we say, 17? Okay, 17. All right, I wanted to do one more with y'all. Number 27. 27. Okay, it's one of the more difficult ones where we have to solve. So let's go over 27. I have the cosine squared of x plus 2 sine x. Oops, nope. Let's scratch 27. Did I give you guys 27? I think I did. Let me see. Double check. 27. I did. Now that I'm looking at it with a little bit more intention, that I'm pretty sure is one of the trig identities we didn't go over, that 2 sine cosine. which it is. Okay, in case you're wondering how you would solve that one, we're not going to go ahead and do it. But one of they're called double angle formulas. In 7-6, the sine of 2x is equal to 2 sine x times cosine x. And if you're trying to figure out like, oh, what I'm saying all this stuff and I haven't even moved my screen back, there we go. Looks like this. Okay, sine 2x equals 2 sine x times cosine x. This is one of our trig identities, which is kind of you memorized to help us use. So you would replace that with, and again, you could probably just skip this part of the video. That's what I would do. And we subtract sine squared x. Okay, equals what? 0. Okay, so you would have to replace this with the sine 2x. So you'd have, well, we're gonna do it. If you want to watch this, if you're interested, you can. But we'll do number 25 as well after this. But if you guys want to watch this, let's try and finish it. So if you knew this identity, okay, that means you could replace this 2 sine x times cosine x with this guy. So we'd have the cosine squared x plus sine 2x minus sine squared x equals 0. And from here, you would probably need to replace this with what? A 1 minus sine squared x. So this is from Pythagorean identity. So 1 minus sine squared x plus sine 2x minus sine squared x equals 0. We have a negative 2 sine squared x, so it would look like this, a minus 2 sine squared x. Unless there's another identity I'm forgetting. Oh, nope, there is one other identity. So we have, let me write it this way. Okay. Sometimes you look at a problem beforehand, you're like, oh, that looks easy, and then you really think about what this is, and you're like, ooh. So we have a 1 minus 2 sine squared x. And, you know, we're not going to finish this one. I will show you one other thing, though, that we needed to do, just to show you how ridiculous this problem was, which is why we skip 7-6 typically, because it's pretty difficult college level stuff. So what did I say? 1 minus 2 sine squared plus sine 2x equals 0. Okay, and this here actually is another identity. There's another identity, a double angle formula that says the cosine of 2x equals 1 minus 2 sine squared x. So that means we can take this plus this and say that is equal to 0. So you got to think there, okay, basically if this is going to equal 0, these two things have to be the same thing. So we're not going to finish it out, but yeah, that's how you would do that one, just for the sake of time. Probably no one's even still watching. Let's move on to 20, what did I say, 25? Yep, 25. Again, I'll have timestamps. Please just skip that whole portion of the video. So 25, we have a 4 sine squared x minus 3 equals 0. This one's going to go much smoother than the last one. Solve for sine squared x. Get that by itself. So we have a 4 sine squared x equals 3. Okay, and by moving the 3 over, adding it, divide by 4, we have the sine squared of x is equal to 3/4. Okay, cancel that square by square rooting both sides. So the sine of x is equal to, make sure to do a plus or minus because we square rooted both sides. Plus or minus, this is root 3 over the square root of 4 is 2, so you can reduce it like that. So we need to think, where is the inverse sine of those? So x equals the inverse sine of plus and minus root 3 over 2. So we should get 4 answers, one for each the positive root 3 over 2, or sorry, 2 for each of the positive root 3 over 2 and the negative root 3 over 2. So if you remember on your unit circle, where do we get these from? That should be at, let me pull the unit circle up. Okay. So sine, remember, goes with y. So we have our positive ones here at pi over 3, 2 pi over 3, and then down here, 4 pi over 3, and 5 pi over 3. So 1 pi over 3, 2 pi over 3, 4, and 5 pi over 3. X pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I hope that helps. On Friday, I plan on doing just, I'm not calling them quizzes or tests. I'm not really sure what. It's just something for me to make sure we're understanding. I'm sure there's a lot of decision making still going on about really about everything. So, but as far as I know, what I want to do with you guys every Friday, do like between 1 to 5 questions, probably no more than 5 questions, we'll say. Kind of progress check to make sure you guys are doing everything that needs to be done. Just for progress check. So we'll call it that. So we'll have one of those this Friday. So if today is Wednesday, we'll have it in 2 days. I'll just post some questions, and I'll hopefully be available again between 12 and 3 to answer any questions that you'd have on that. And that will be due basically on the following Monday. I'll give you guys the whole weekend to work on that, just in case you can't get to it right on Friday. Again, this is going to be a huge learning curve for both me and you guys, figuring out how to do this all online effectively. So hope you guys are doing well. I miss you guys. Hope this helped, and I will talk to you next time. See you later.